right? So let me take one example, the character height. So what he would do in one of his experiments is he would take a pure tall pea plant and then cross-fertilize it with a pure short pea plant and then see what offsprings they would give. Now, I'm pretty sure you may be wondering, what do you mean by pure plants? What does this pure mean? Pure basically means if you were to self-pollinate them, so if you were to self-pollinate a tall plant, it should give all tall plants. If you self-pollinate a short plant, it should give all short plants. And what do you mean by self-pollination? Well, suppose this is one of the flowers of the tall plant. Then what I mean by self-pollination is you take the, what do you call this? Pollen grains, yeah. You take the pollen grains from the flower and put it back into the carpel of the same flower. Basically, you put it back into the female reproductive part of that same flower. And then it'll grow seeds, and then you sow those seeds. And then if you find that all the seeds grow into tall plants, then we will say this is a pure tall plant. This is the meaning of pure. And similarly, if you were to do the same thing for the short plant as well. So you take one of the flowers of that short plant and then you self-pollinate, meaning you take the pollen grains, put it back into the same flower, let it fertilize, and then you grow seeds and you sow them. And if you find all of them grow into short plants, not a single tall plant, but all of them grow into short plants, then we will call this a pure short plant. Okay, so Mendel prepared these pure breeds for his experiment, a pure tall plant and a pure short plant. Let me get rid of these now. And so for his experiment, you know what he does? He cross-pollinates them, meaning he takes the pollen grains from one of the plants and he puts it into the flower of the other. And you can take it from anyone to anyone. So for example, he might take the pollen grains of flower from the tall plant and then put it into the carpel or this part of the short plant. So let's say he cross-fertilizes them like this, and then this will start growing seeds. Then he sows that seeds to see what we will get after this cross-fertilization. So what do you think we will get? Well, let's get rid of the flowers and make some space. So what do you think we end up with? Well, I would expect to get some medium height plants, right? Because you have a short one, you have a tall one, you have a short one. So maybe they get mixed and you end up with all medium sized plants. That's reasonable to think, right? But to Mendel's surprise, and to even my surprise when I learned this, we get all tall plants. What? That's right. Big shock. 100% of them end up being tall. This raised many questions. What happens to the short one? Does it have no effect at all? Why aren't we getting any medium-sized plants? Why aren't we getting any short plants? What is going on? Anyways, he addressed these plants as F1 generation plants. That's just the name that he gives them. And if you are wondering why he called them F1, the F stands for a Latin word filial. I hope I'm pronouncing that right. It means son or daughter. Okay. So that's why these plants are called F1 generation. First generation sons or daughters of these, you can say. But yeah, Mendel was shocked by this. So he didn't stop over here. He started asking questions. One of the main questions he was asking is, are these plants, these tall plants, the same as the parent tall plant? Are they same? They look the same because they have the same height, but are they really the same? Is this also a pure tall plant? That's the question he started asking. And to answer that question, you know what he did? He did another experiment. He didn't stop over here. What he does next is he takes one of the F1 generation plant, which is basically tall. He takes one of the F1 generation plant. This is F1 generation. Oops, let me use this white color. So this is F1 generation. And he self-pollinates it. Self-pollinates it to see what we get. So again, it will grow seeds and then he sows that seeds. What do you think we'll end up with? Well, surprise, surprise. Now, some short plants are found. Another shocking thing to see, right? Because again, where did these short plants come now from? Suddenly, right? And guess what? Mendel even counted them. So in this F2 generation, this is the second generation sons and daughters or offsprings. When he counted them, you know what he got? He found that there were roughly 3 times as much tall as you had compared to short. So the tall to short ratio was 3:1. And if you're wondering, yes, he also cross-pollinated the F1 generation plants and he gets exactly the same result, 3:1. And you know why this number is so important? Because it's not random. It turns out he gets the same answer for all the characteristics that he experiments with. I mean, for example, when he takes the color of the flower into consideration, again, he takes a pure purple colored pea plant and crosses it with a pure white pea plant. In the first generation, you know what he gets? A similar result. This time he gets all purple colored flowered, no yellow, no white flowers at all. But then when he takes one of these F1 generation purple flower and self-pollinates, guess what he gets? He now gets 3 times as much purple as white. White comes back. It's in minority, some small amount, 3:1 ratio, but it comes back with the same ratio, 3:1. So what's going on? Why didn't we see the white flower over here, but somehow it comes back in the next generation? What is going on?